explain very fast now. In a titration experiment, so 21.60 cm cube of tetroxysulfate 6 acid was required to completely react with 25.0 cm cube of caustic soda. So, containing 2.0 grams of the alkali, that is that alkali which is caustic soda. Alkali means base. Alkali, when they say alkali, it means a soluble base. But when they say alkaline, that means a base that is not soluble. Alkaline as in L-I-N-E, alkaline. So, okay, Prodigy, you said something now. Alkaline is the non-soluble one. Why the insoluble? Why the alkali are soluble bases? So A is the first question. Write a balanced equation for the reaction. Normally, you should decide the reaction between tetroxysulfate 6 acid, H2SO4, and caustic soda. That's a very, very strong reaction. H2SO4 is a very strong acid, the strongest acid. Let me move towards system. I'm going to kindly spare some seconds, please. I want to shift my chair. I want to plug my phone. Okay. Yeah. So we said it is H2SO4 and NaOH. So it is logical that we can say H2SO4 is a strong acid, is a very strong acid. And NaOH is a very strong base. So that means it's a very violent reaction. It's neutralization reaction. That's all we know. So now we are going to see this sodium is going to react with this SO4 here. And water is going to react, hydrogen is going to react with hydroxyl ion here. So water will be formed and salt will be formed. That's neutralization reaction. Neutralization reaction involves the formation of salt and water. Are you guys seeing my screen like this? Is it not too dull? Are you guys seeing my screen now?
Yes.
Okay. Okay. So now, the first thing is H2SO4 plus NaOH. We are going to get Na2SO4 plus H2O. We have to balance the equation. Why are we balancing the equation? That's conservation of mass. The amount of things we have here, the reactant must be the same with the product. Sodium we have here is 2 moles of sodium. So sodium we have here must be 2. We have 2 atoms of sodium here, 2 atoms of sodium here. We have 2 and 2. That's 4 atoms of hydrogen here, and we have 4 atoms of hydrogen here too. We have 6 atoms of oxygen here. We have 6 atoms of oxygen here too. We have 1 atom of sulfur here and 1 atom of sulfur here. So our equation is balanced. That is what we mean by balancing equation. What you have at the right hand side must be equal to what you have at the left hand side. So concentration of caustic soda in most of them now. My network. My own network. What's wrong with it? Some people's video are paused due to problems with my network. Is everyone seeing this thing?
Sure, we can.
Yes, I can see it.
It's bringing the message, so that's why I have to talk. So concentration of caustic soda in moles per dm³. We are given the mass of caustic soda here now, and we are given the volume at which the mass is present in. So we need to look for the mass concentration first. We call the mass concentration normality. It is equal to the mass over volume in dm³. What is the mass? 2. Over what is the volume of dm³? You change 500 cm³ to 1 dm to dm³. It's going to become 0.5 dm³. They say 10 centimeter make 1 decimeter. So 1,000 centimeter cube is going to make 1 decimeter cube because it has become cube. That's the logic. 10 raised to power 3. So now 2 divided by 0.5 That is the volume in DMQ. 2 divided by 0.5 gives 4 grams per DMQ. We already have the mass concentration of caustic soda. Mass concentration
Ta ló ń bá a ṣe? Nǹkan ayọ̀ náà ló ń ṣe. Orígbóye rí.
So molar concentration equals mass concentration over molar mass. This is where we can use this thing now. We've calculated our molar mass. Our molar mass is always equal to addition of the several components, the mass number of the components of that compound. Mass number of sodium is 23. Mass number of oxygen is 16. Mass number of hydrogen is 1. We're going to get 40 grams per mole. So molar concentration should be equal to mass concentration over molar mass. So what is the mass concentration gotten? That was 4. Molar mass gotten 40. So 40 divided by 4 divided by 40, we are having 0.1 moles per DMQ. If you want to confirm why your unit is mole per DMQ, then just write 4 grams and 40 grams per 4 grams per DMQ and 40 grams per mole. Grams cancel grams. Mole from this interval becomes up, so it becomes moles per DMQ. That's logical. So the next question says, look for the value of the concentration of the acid in moles per DMQ. This is where we use the concentration formula. CAVA over CBVB equals to NA over MB, where Ca is the concentration of A in moles per DMQ. VA is the volume of A in CMQ. CB is the concentration of B in moles per DMQ. VB is the volume of B. And NA is the number of moles of A, while MB is the number of moles of B. We are looking for the concentration of A in moles per DMQ. That is Ca. Making the Ca the subject of the formula now, I have Ca equals to CBVB NA over VAMB. What is our Cb? We calculated it here. Molar concentration, that's concentration mole per DMQ for base. 0.1 times VB. That is the volume of the acid given to us. That was 25. Times number of mole of the acid. What is before the acid here? What's at the front? Nothing. So it means 1. It's not 0. If it is 0, then nothing will be there. Parameter, there will be compound 2. So, but it means 1 here. 1 times this thing. So it's like saying 1x. So times 1 over VA, that's the volume of the acid used, that's 1.60, times NB, that is the number of mole of the base reacting with the acid, that is 2, after balancing our equation. You see the essence of balancing equation is very important. So we have 2.5 divided by 43.2. We are getting 0.0578 moles per DMQ. That is the concentration of the acid in moles per DMQ. And on now. So the last thing is now the concentration of the acid in grams per DMQ. Concentration of the acid in grams per DMQ. Using the formula that connects it to the concentration of acid in moles per DMQ. Since we got that and the molar mass, we can calculate that. Molar mass of the acid is, you add the components of the acid together, their masses, you're going to get the molar mass times the formula mass over raw mass. So molar mass of the acid is hydrogen is 1 times the 2 that is at the base. So we have 2 atoms of hydrogen here. That's 1 times 2 plus sulfur is 32. We are talking about the mass numbers, atomic mass, not the atomic number. This is the atomic mass. We call it 32 plus oxygen is 16 times 4 because it is 4 atoms of oxygen that we have it. Doing the mass here, we're getting 98 grams per mole. So concentration of H2SO4 in moles per DMQ equals to concentration of H2SO4 in grams per DMQ over molar mass of the H2SO4. This is the formula. We are going to make concentration of H2SO4 in grams per DMQ the subject of the formula. So concentration of H2SO4 in grams per DMQ equals to concentration in mole per DMQ times molar mass. That's by cross multiplying. I'll snap this and send too. So by cross multiplying the values we have, in mole per dm cube, we got it earlier, 0.0578. Multiply by the molar mass we got over here, that's 98. The both of them are giving us 5.66 grams per dm cube, which is approximately 5.7 grams per dm cube. So any question again from anyone? Any question, please? Any question? I'll take it as no question since I'm just I don't have time to waste too.
There's question, no, there's question, okay?
Okay. Yes, now you guys should be relying so fast. All of us don't have time. I'll say any question, no one will answer.
Yes, so please, I'm sorry about the calculation. Like, because when you are recap, I was checking it and I'm doing the calculation back again.
Okay.
So when we divide this 2.5 divided by 43.2. So what I got there is 0.05787.
Okay, 0.0579, Abby.
Yes.
Okay. That's also to be considered. But even if this is the issue, if you are doing theory, if you still get this thing got, there's no problem. Moreover, it is those of you that calculated it. You understand?
And you know that we applied the final question, like this final one.
Will it really affect it?
Yes.
That one is
5.6.
Ali, I think she is wrong. The answer is still 0.0578.
See, that one is both of you can fight about it later. Maybe you have a number and she has your number too.
No. As in, we just need to. I think I understand that, like, but we just need to.
I understand that.
Calculation, serious. I've done it twice.
It's not the only one may hear your voice. I know. Don't.
Those are minor questions now.
Stop. Please proceed.
I don't want problem.
You want peace on you, Daddy?
Person should do another person calculate it.
Calculation alone.
Hello.
Okay, we want to use it like that. Now your calculation.
Mr. Bamikoli, what do you have to say?
You and Ali.
Hear me, please.
What do you say?
Yes, can you hear me now?
Yeah, I can hear you now.
Okay. Well done for all you are doing. I'm joining you for the first time tonight. I've been trying to talk to you, but I think it was network. Please, can we get the questions? Can you try to send the question on the can you post the question and the answer and the screenshots?
Okay. I'll do it immediately after this class. Into a group. Are you in the group?
What is it? I don't know. Maybe I'm in the group. I don't know. Someone sent this thing to me, and I'm joining for the first time tonight. So I don't know.
I think you will have to leave your.
I think I
leave your number. Someone will have to do.
All right. I think I'm in the group. I'm sending it right now. Thank you.
You're welcome, sir. So you'll be added to the group. Everything will be posted in the group after this class. Moreover, there will be a video. There will be this video, the whole of what's happening here. We have one of us here that is recording it. So he will surely post the video for us too. So don't worry.
All right. Okay.
Is there any question from anyone? Okay, Miss Aminat. Calculation, Abi. Okay, another person. Any question? Okay, now that's all about what we wanted to teach. I think we should leave it that way. Though I actually had some more questions, but I promised myself 10 o'clock. It's over 10 now, but I want to recap what we actually did here now. Chemistry 191 was what we treated, and is what we treated rather. We talked about the concept of mole, mass number, normality, molarity, molality, and percentage purity, which we didn't do any workings involving percentage purity. So we said the number of mole is just the amount of elementary entices that is present in an atom. So that is mole. It is the amount of it is the amount of that things present in that atom. So if I say 1 mole of an atom now, that means the amount of the thing that made an atom that is present in that atom is 1. If I say 2 moles of the atom, that means the amount of those things that made up the atom becomes 2. It has been doubled. That's what I mean by mole. So we said the mole calculated by several formulas. I just forgot. I don't know my problem now. I only remember 3. I have about 5 formulas we can use to calculate mole. I forgot them, to be sincere. So mole is mass over molar mass. When you have the mass number and you can get the molar mass, you have the molar mass, you can get the mole. That is, calculate the mole of 5 grams of hydrogen gas. Hydrogen gas, the molar mass is going to be mass number times the 2. Hydrogen gas is H2. That will be 1 times 2. So mass is 2 grams over molar mass, 2. So the number of mole will be 1. 1 mole. The unit is MOL, mole. So now we can also calculate it by using number of particles of Avogadro's constant. Number of particles, it could be number of ion I mean, ION. It could be number of molecules, it could be number of atoms, while Avogadro's constant or Avogadro's number is 6.02 times 10 raised to power 23 mole. I'm going to snap all this and send. Mr. Temi or Miss Temi or Mrs. Any issue? Speak out, please. Okay. So mass number equals to number of protons plus number of neutrons. Number of protons plus number of neutrons gives what we call the mass number. Okay, calculator. Prodigy, your not too much. Okay, so I said number of protons equal to the number of neutrons plus number of the mass number equals to number of protons plus number of neutrons. So now, normality, that is concentration in grams per dm cube. Before they call it normality, now it is being called mass concentration. So molarity, that one is concentration in moles per dm cube. Though we still call it molarity, but we all commonly know it as molar concentration. Molar concentration. And molality is mole in kilograms. So now, I think percentage purity now, amount of pure of that substance, amount of pure substance in that compound over the amount of the overall compound or the impure compound times 100 will give us the percentage purity. So that's my case here. Everyone, I think, okay, if there's any question, please. Any question, signify, please. Kilograms. So that is the logic. You can explain better if there's nothing. Okay, any question again? Odigi, what's happening at your end this night? Any question from anyone? Okay, if that's the case, I'll humbly leave the group. I get things to do.
Sorry,
Any question?
I think I'm still confused with that molality and normality. Something I don't understand.
Hey, I don't know how many times I'll talk about. Listen again. Listen, bro. Normality. Normality is that thing you always call mass concentration. Do you hear? So that's the normality. So anyhow you are calculating mass concentration, just know you are calculating normality.
Yeah.
So as for molarity, anywhere you are calculating molar concentration, know you are calculating molarity.
Okay.
So the last one now is not common. We don't really use it in calculations. That's why it doesn't sound familiar. It is molality. So that molality means mole per kilogram. number of mole of that compound
in
or that
1 kg.
substance in 1 kilogram of
Okay,
solid.
I've seen what I need. Thank you. Yeah, I get. Thank you.
Thank God. You're welcome. Yes. Yeah.